As promised, this is your Unit 5 Linear Relations test review. In this video, I'm going through each of the questions on the test. Now, if you knew you got a question correct on the test, well, you can skip over those parts by just going forward in the video and focus on the questions you needed help with. I hope this helps. Alright, to answer this question, first you must read it. Sketch the following story. Begin 5 meters from the wall. Walk towards the wall for 5 seconds at a slow, constant rate. Stop for 5 seconds. Run back to your starting position. So the first thing I need to do is I need to put the numbers on the y-axis. So this will be 1, 2, 3, 4, 5. And I can do this because I can see the furthest away from the wall is going to be 5 meters. The second thing I need to do is then label my x-axis. And you get the idea. This goes on and on and on down to the end, labeling each one equivalent to 1 second. The second thing I now need to do is start with A, or the third thing I should say. Begin 5 meters from the wall. 5 meters from the wall at 0 seconds will be at this point here, which I am attempting to identify for you. Alright, I'm 5 meters from the wall at 0 seconds. Then it says, walk towards the wall for 5 seconds at a slow, constant rate. Okay, so he's walking slowly, it's a constant rate, so I know the line should be straight. And for 5 seconds. Alright, so if I identify 5 seconds, slow constant rate, you'll have to excuse the fact the line is not straight. I can't use a ruler on this. Okay, so that's about 5 seconds there. Imagine that line is completely straight because it's a constant rate. Then it says stop for 5 seconds. So now I'm going to stop for 5 seconds. When I'm stopping for 5 seconds, it means the distance from the wall is not increasing. Okay? So I'm stopping for 5 seconds means it's going to have a slope of 0, and I'm going to go a straight line from there for about 5 seconds. You'll have to excuse the inaccuracy of the stylus I'm using. Run back to your starting position. Now, when it says run back to your starting position, it does not mention if the rate is constant. And as we've discussed in class, we know that running is not a constant rate because you have to start running to get up to your speed. For that reason, I would draw a curved line. It says to your starting position, it doesn't say run to the wall, so as a result I know that I'm going to be curving my line upwards rather than downwards because I'm going back to my starting position and not to the wall. Question 2. If a wheelchair ramp has a rate of change greater than 0.1 in size, then it is considered unsafe. Determine whether or not the following ramps is safe. That should say ramp. Show your work and explain your reasoning. So for this question, I got to look at rise over run because rate of change equals rise over run, and you should all be familiar with this by now. Rise over run. Okay, what's my rise here? Well, my rise is 30 because that's how much the ramp goes up. So 30 over. My run here is 240 because that's how long the ramp is. So that's 240. 30 divided by 240, if I do that in my calculator, and I end up with the number 0.125. Now, some students got this question correct when they did the calculation, but then insisted that it's not safe, or sorry, that it is safe, because it is less than 0.1. However, 0.125 is greater than 0.1. Therefore, this ramp is not safe. So it says here, explain your reasoning, and many people have problems with that. All you need to do here is say, the ramp is unsafe because 0.125 is greater than 0.1. Question number 3. Calculate the rate of change of the staircase below from A to B. This question gave a lot of students fits. I got questions like, well, how can I do this if there are no numbers on the graph? To which one of my hairs fell out of my head. You don't need numbers to do this question. Let's see how we would do it. First, what are the points you're trying to compare? You're trying to compare points A to B. This was one of the problems people ran into. They did not compare points A to B. They sometimes circled A and then chose random points to compare to. For example, some people decided they were going to compare A to this point over here. But that's not point B, so that would not be correct. Let me get rid of that for you. Point B is here. Okay? So what do? I draw a line from A to B. You should have a ruler. Your line should be much straighter than my own. Once I've drawn that line, then I'm doing the simple thing we've learned on how to calculate rate of change. First, I'm going to find the rise. There's my rise. Okay? How many spaces is it? 1, 2, 3. 1, 2, 3. So that makes the rise 3. Then I'm going to find the run. I go from A to over here, horizontally to where B is, and I count those. 1, 2, 3, 4, 5, 6. 6. Well, rate of change is rise over run. So rate of change, rise over run, equals 3 over 6. I could simplify that to 1 over 2. And then in standard form, I'd express that as 0.5. Question 4. Arcadia charges players a $15 admission fee to their gaming center. Arcadia also charges each player $5 per game. A. Write an equation to model the cost of playing games at Arcadia. In order to do this, I need to remember the linear equation formula, which is y equals mx plus b. First that I can identify is $5 per game that we see here. When I see a unit rate like this, $5 per game, that means when I'm putting it into my equation, I'm going to always be multiplying 5 by the number of games that someone plays. So if I played 4 games, I multiply 5 times 4. Okay? And I also know, because it's a unit rate, and I'm going to be multiplying it by the games as I enter those numbers, the number of games into the equation, that it is my slope. And m here means slope. So I'm going to make y into c because we're looking at cost. Now I know the slope because m is the slope and it's $5 per game. So 5. I'm going to make x into n to represent number of games. And then plus b, that's where we now need to put in the admission fee because that's the flat rate you have to pay just for going in. Also be thought of as the base fee. So we write that in. And there I have the equation. B. What is the rate of change for this relation and how does it relate to the cost of playing games at Arcadia? Well, as I said, m represents the slope. 5 is therefore the slope. So for B, answer is 5. Okay? But it also says how does it relate to the cost of playing games at Arcadia? Well, it's 5 because the cost is $5 per game. Okay, so $5 per game. Easy enough. What is the initial value for this relation and how does it relate to the cost of playing games at Arcadia? So B is our initial value. It's also our y-intercept and it's the number 15. So my answer is 15. But it also asks us again, how does it relate to the cost of playing games at Arcadia? And you would simply say there is a $15 admission fee. Question 4D asks us to graph the relation. So just to recap, our equation was 5n plus 15. So a lot of students had trouble with the graph portion of the test, first and foremost because they did not give a title. So let's do a title first. You could do comparing the y-axis to the x-axis, or you could do a general one like cost of playing at Arcadia. Hopefully your printing is neater than mine with this stylus here. Okay, and the next thing they often left out was identifying the y-axis. So our y-axis, which is our dependent variable, in this case is going to be cost. And we've discussed this in class. Cost, if you're doing something where you're trying to find out how much things cost, is always going to be on your y-axis. It's because it's the dependent variable. It depends on how many games you play. So let's identify then the x-axis. The x-axis is going to be number of games. Okay. Then now we have to create the interval for the axis. We have to put the numbers on the different axes. And what we'll do, because we know it's going to go up by 5, the easiest thing to do here on your y-axis is just to label them by 5. 15. 25. And I'll stop there because you'll be able to get the point of what I'm doing before I go any higher. So 1, 2, 3, 4, and 5 down here on the x-axis, because then we can figure out how much costs for each game. And I'm not going any further again because you'll get the idea before we go further. So then, what do we have to do? We know that our first point on the graph is going to be 0, 15. And how do we know that? Well, we know that because if I put in 0 games, put in 5 times 0 plus 15, I end up with 5 times 0, which is 0 plus 15. So I end up with 15. So that means point 1, x-coordinate, is going to be 0. And the y-coordinate is going to be 15. So 0, 15 is here on the graph. Okay, 0, 15 is there. I saw a lot of students mislabel 0, 15 and put it here. That's not correct. This would mean after one game you only pay $15, but what we know is at one game it's going to be more than $15. At 0 games it is $15. So let me get rid of that point. So 0, 15. How much is it going to cost after they play one game? Well, one game costs $5 plus the admission fee that we already have, which was $15. My next point is going to be here. And how much is it going to cost after 2 games? 2 games, 5 times 2 equals 10, plus the 15 I already had, we have 25. And you should get the pattern by now that it's going to go up by 5 each time because it's $5 per game. So the rest of my graph would look like this. These points are all supposed to be right on that intersecting point. If they're not, it's because of the stylus. Okay, and your points would go up and up and up. $5 per game. So you can see here I've done a good graph because I've got a title. I've labeled my x-axis over here. I've labeled my y-axis over here. And I've put my points where they should be. This would be full marks. Of course, you'd want to have the numbers going up the y-axis and all the way down the x-axis. I haven't done that here for brevity's sake. 4E. How many games can Jeremy play if he has saved $60 for a day at Arcadia? So in order to answer this question, I need to recall that there was a $15 admission fee and subtract that admission fee from the $60 so I can find out how much money Jeremy would have left over to play games. So I would do 60 minus 15 and that equals 45. Now I have to recall that it costs $5 a game, so in order to find out how many games you could play, simply divide 45 by 9. Sorry, getting ahead of myself. Divide 45 by 5, because it's $5 per game, and that gives me the answer 9. F. How much will it cost Renee to spend a day at Arcadia if she plays 30 games? And so with this one, what I can do is I can plug in the value into the equation that I wrote earlier. If you recall, N represents number of games, so I can plug it into there. So 5 times 30 plus 15 equals 150 plus 15, and 150 plus 15 equals 165. So Renee would spend $165 if she played 30 games. Alright, G. How would the graph from A change if Arcadia decreases the admission fee to $10? And this is an older version of the test. I'm sure I put change into the test that you wrote. So how would it change if Arcadia decreases the admission fee to $10? Well, if you recall, the graph that we made earlier looked like something like this, and that point there was 0.15 on the graph. Well, if the admission fee decreases to $10, well, that just means that the line, the graph, is going to start a little lower on the y-axis. So that's all I would need to write down. The graph starts lower on the y-axis. Alright, so the other part of 4G asks, write an equation that represents the new cost of a day spent gaming at Arcadia. And so to do that, I know that the admission fee has changed to $10. That means the initial value has changed to $10, and our y-intercept will be 0.10. And so simply I just have to rewrite the equation with, instead of 15 at the end, I'm putting 10 at the end, and my slope has stayed the same, so it stays 5n, and I just put plus 10 instead of plus 15. Alright, 4H, how would the graph from A change if Arcadia charges an admission fee of $10 and increases the cost per game to $7? Well, if you increase the cost per game from 5 to 7, well, what's going to happen to your line, which was like this before, it's going to become steeper. And that's all I would have to write here. The graph would become steeper. And the other part of 4HX tells us to write an equation that represents the new cost of a day spent gaming at Arcadia. So the new cost would be C equals, my cost per game changed to $7 per game, so my slope is now 7 instead of 5. And it says here admission of 10, so my initial fee is $10. And my new equation would be C equals 7n plus 10. Here's another question that gave some students some trouble. Number 5, the local swimming pool is open 5 days a week for 8 weeks during the summer holidays. The admission prices are displayed at the entrance. Splash World Swim Park price list. Seasons Pass, $60 plus $2 per day. Daily Swim Pass for $5. That's $5 per day, obviously, because it's a daily swim pass. So how much will it cost one person to go to the pool every day the pool is open in the summer? Now remember, it said it was open 5 days a week for 8 weeks. So to find that number first, we have to do how many days it's going to be open, and so we can know how much will it cost for them to go each day. We would do 5 times 8, and we would get the number 40. So we know that it's going to be open 40 days. Then we can look at how much each one will cost now that we know the number of days. So if it's $2 per day for the season's pass, we need to do 40 times 2, and we get the number 80. And then we have to add the $60 you had to pay for the season's pass. So 80 plus 60 equals 140. So that's how much the season's pass will cost, 140. And then for the daily pass, it's $5 per day. So 40 days times $5, and we end up with a value of 200. 5b, write an equation that represents the cost of a season's pass and an equation that represents the cost of a daily pass. So again, we're working with cost, and we're trying to find the cost, or write equations that'll help us to find the cost. So C is going to be my dependent variable. And for the season's pass, I recall that it costs $2 per day of swimming. So 2 is going to be my slope, because the graph is going to go up by 2 each time. And then I'm going to put n for the number of days swimming. And then, if you recall, there was a $60 base fee for the season's pass, so I would put 2n plus 60, and that is my season's pass equation. Alright, and now for the daily pass. Again, we're working with cost as the dependent variable. We know that it costs $5 per day, so we know that that's our slope. And we put in n for a number of days that you go swimming. We also know that the y-intercept is going to be 0. There's no base fee, so we don't have to add anything here. There's no plus anything, definitely not a plus b, it's just c equals 5n. Okay, 5c, graph both relations on the same grid. A lot of students had trouble with this because they weren't sure how can I put more than one line on the same graph. It's very simple. You create the graph and then you put 2 lines, but maybe it doesn't feel simple for everyone. I'm going to go over it again with you here. So the first thing I want to do is I want to give my graph a title. So my title will be, I'll use the comparing the y-axis to the x-axis, or the dependent variable to the independent variable. So it'd be cost versus number of days swimming. And yes, that's my title. And then I want to label my y-axis. So to label my y-axis is going to be cost, because that's the dependent variable. It will depend on how many days I go swimming. And then I'm going to label my x-axis. That's going to be number of days swimming. Alright, the other thing that gave students difficulty was putting the numbers along their y-axis. I mean, you could have used 5 and 10, but then you would not fit all your, an interval of 5 or 10, but then you would not have fit all your data onto the graph. I used 20 because that would enable me to label my entire graph. So you can see I labeled my y-axis. The next thing I would need to do is to label my x-axis. And if I do 1, again, I won't be able to fit all my data on the graph, so I could label it as 5, or make it have an interval, I should say, of 5, and then I would end up with a graph that looks like this. So I've labeled my x-axis. You can see it only goes up to 40 because the data that I have, or the number of days you could possibly go swimming in the summer, only goes up to the number 40. Alright, so then what would I do next? Well, for the season's pass, I know that there is a $60 fee that you have to pay up front for the season's pass. So even though you've gone 0 times, you're still paying $60 if you buy the season's pass. So my first point is going to be here at 0.60. Where would my next point be at? Well, it's $2 per day for 5, so that would make it at 70. So I'm going to try to put it in the middle here. Hopefully it works out. My next point would be here in the middle. And that represents that it costs $70 to go 5 times to the pool with a season's pass. Then what would it be at 10? Well, it's going to go up by another 10 because 5 times 2 is 10, and it would cost me $80. So my next point would be here. And 15, again, it's going to go up by another 10, so my next point would be here at 1590, and so on and so on. Excuse the messiness. Okay, so that would be my season's pass, and I would of course draw all the points in the graph, and I would end up with a line that looks like that, but much straighter, hopefully. Okay, then what about for the daily pass? The daily pass is $5 per day. So if I go 0 times to the pool, it will cost me $0. Okay. If I go 5 times to the pool, it will cost me $25, which would be a smidgen above this line here. And if I go 10 times to the pool, it'll cost me $50. So if I go 15 times to the pool, it'll cost me $75. So that's going to be a little bit above here. Oops, I'm on the wrong point, right here. Let me erase that other one for you. Okay, then how about at 20 times? 20 times 5 is 100, so that part's going to overlap with my other graph. It's going to be on this point here. This point here on my graph. At 20 days of swimming, the daily pass cost me $100, and the season's pass also cost me $100. So what's significant here is that once I go beyond 20 days without a season's pass, I will be paying more to go swimming that summer. So where is it going to be at 25? At 25 times 5 is 125. Now it's going to be here, or thereabouts. Alright, and then probably actually a little bit lower than that, so I'll just fix that a little bit, hopefully. Okay, then at 30 days, 30 times is going to be 150, so it's going to be neat for me to put right here. Let me get rid of that arrow. Write that point in better. 150. Okay, and on and on and on, and what I'll end up with is a line that looks something like this. Of course, much straighter. And you can see that after 20 days, it costs more to have a daily pass. And it's cheaper to have a season's pass if you're planning on going more than 20 days. This brings us to the last question of the test, 5D, which asks which pass is better. Well, the answer to this question depends on how many times you are planning to go swimming that summer. If you recall, our graph looked something like this. And the point where the graphs intersect is here. That point was 20, 100. Which means for the daily pass, it costs you $100 to go 20 times to the pool. And also for the season pass, it costs you $100 to go 20 times to the pool. In which case, the season's pass is better. Season's pass is better if you are going to the pool more than 20 times. And correspondingly, the daily pass is better if you go less than 20 times. At 20 times going to the pool, the daily pass and season pass are completely equal. If you go 19 times or fewer, the daily pass is better. If you go 21 times or more, the season's pass is better. This concludes our test review. Hope it helped.